Today we will be talking about 1.8a or just 1.8, Introduction to Composite Functions. The most important thing to know about composite functions. So composite functions is just when you take two different functions, let's say an f of x and a g of x, and you smush them together using different operations. The important part to remember is that the f of x and g of x, the rules that applies to integers, meaning numbers, when you do operations like adding, subtracting, dividing, multiplying, applies to composite functions. So you can add composite functions, right? You can find the sum, which is f of x plus g of x, or it could look like f plus g of x. That is a sum. A difference is kind of like your sum, except you're just subtracting. A difference is pretty much a sum of one of them being negative. So f of x minus g of x, or it could look like f minus g of x. And product could be f of x times g of x, or f g of x. And then finally our quotient, which is f of x over g of x, or f over g of x. These are just fancy notation for saying find the sum, difference, product, and quotient. So let's do an example. Okay, so let's say I had, let's say f of x equals x squared minus 2x. And let's say g of x equals x plus 3. If we were to add them, right, if we were to add them, f plus g of x, if we were to add them, then they would go x squared minus 2x plus x plus 3. We're left with x squared minus x plus 3. And that would just be our answer right there. If we were to subtract them, f minus g of x, then it would be x squared minus 2x, and the next numbers will be negative. So then we're left with x squared minus 3x minus 3, just like that. And let's say we multiply. Well, this becomes more interesting. If we multiply f of g of x, then we would have to FOIL, right? Because this is two binomials, and if you're multiplying binomials, we're FOILing. So this becomes what? X cubed plus 3x squared minus 2x squared minus 6x. Combine the like terms, so we have x cubed plus x squared minus 6x. And then finally, if we were to divide, let's say f over g of x, this would be our answer back up here with multiplication. If we were dividing, we would just leave one on top of the other. X squared minus 2x over x plus 3. The important part is to know our domain. Our domain here, when we do the division for our quotient, is that x has to be greater than greater than what, -3? X has to be greater than -3. However, we were to write that, we would say here from -3 to positive infinity, that would be our domain right there. While we're on the topic of domain, let's say we had an interesting domain. Let's say if our domain happens to be, let's say if we ended up with an equation that said 1 over x squared minus 9. We know that x squared minus 9, it factors to x plus 3, x minus 3. So we know that x cannot equal -3, and it cannot equal +3. So if we were to write that as a domain function to our domain, we would say, okay, well, from negative infinity to -3, it could equal, it could be that. And then somewhere in between, right, union, it could be between -3 and 3. So then we do -3, comma 3. And then a union 3 to then positive infinity. The parentheses saying it goes up to that point, doesn't equal it. So that is how we would write the domain for such a function. Let's go back up to our equations up here. What if they wanted us to do f plus g, but instead of putting in x, right, they don't want an x as our answer. Let's say we have f plus g, they want an f plus g right here. And let's say they want us to put in a number, let's say 2. So all we have to do is just go back to our what we got as f plus g. So x squared minus x plus 3. X squared minus x plus 3. Then we're just going to put in 2 wherever there is an x. So this becomes 2 squared minus 2 plus 3. So 4 minus 2 plus 3, which gives us, what, 5? So our answer would be 5. But they could also say, oh, instead of just saying a number, we have f plus g and x minus 2. Not x, but let's say t minus 2. Say t minus 2 is what they want us to put in our equation. Well, we would just take our regular equation that we have, and then wherever there's an x, we'll just put in t minus 2 for our x, and then expand accordingly. First one is to the square power. We need to FOIL that. So that's what, t squared minus 4t plus 4. Then the next part is what, minus t plus 2 plus 3. And then we're just going to combine the like terms. We have then t squared minus 5t, 4 plus 2 plus 3, what that is 9, right, plus 9. So then that is our answer. And that is all for 1.8a.